Have you at any point investigated whether we're really alone in the universe? On the other hand, have you considered that there's something more to our existence than what we see? Envision what's going on if the James Webb Telescope finally shows that we live inside a black hole. It could force us to rethink everything we know about the universe. This critical news will make you question all that you thought you understood about existence. So, what exactly are black holes? They're like something out of a terrifying dream. Sure, you might have seen them in science fiction movies, but in reality they are truly astonishing and frightening. As shown by specialists, black holes in space are believed to contain massive amounts of matter compressed into an exceptionally small region. Think about a star, typically larger than the Sun, condensed into a space the size of New York City. The gravitational pull is so strong that nothing, not even light, can escape. Specialists have been fascinated by black holes for decades. They have studied objects in space that are so enormous and dense that they can trap light. The most famous theories about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star collapses, it leaves behind a dense core. If the mass of this core is a few times that of the Sun, gravity overwhelms everything, leading to the formation of a black hole. Detecting black holes is no simple task since they do not emit light. However, scientists have found ways to infer their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar material, it will pull that matter toward it in a process called accretion. Additionally, when an ordinary star gets too close to a black hole, it can be destroyed, emitting X-rays as it does so. Black holes also have a significant impact on their surroundings. They can consume nearby stars, release powerful radiation, and even influence the formation of new stars, either accelerating or slowing down the process in certain regions. But where do black holes come from? Imagine stars, once enormous and powerful, meeting their violent end in a stunning event known as a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached the end of their life cycle in a supernova explosion. Smaller stars, when they die, turn into what many refer to as neutron stars, extremely dense but not dense enough to trap light. However, if a star is several times the mass of our Sun, it collapses under its own gravitational force, forming a black hole. As this collapse occurs, something strange happens near their surfaces. Time itself begins to play tricks. From the perspective of an observer far away, time appears to slow down near the event horizon, the final boundary for anything falling into a black hole. It's as if the star's clock ticks at a different speed compared to ours. Sometimes, when two smaller black holes collide, they merge into a much larger and more formidable black hole. And if a black hole interacts with a neutron star, they create a massive cosmic nightmare that defies comprehension. Scientists have been grappling with the immense scale of these mysterious objects for years. Black holes come in two primary sizes, large and small. However, small is relative when it comes to black holes. Stellar mass black holes, the remnants of giant stars, can be 10 to 100 times the size of the Sun. There could be anywhere from 10 million to a billion of these in the Milky Way alone. That's an astonishing number of black holes, each capable of swallowing anything in its path. But wait, there's something even more epic. Supermassive black holes exist on the extreme end of the spectrum. They are millions, if not billions, of times larger than the Sun. These enormous black holes are found at the centers of massive galaxies, including our own Milky Way. It's like a massive dead space pulling everything toward it. Renowned physicist Stephen Hawking studied black holes throughout his life. His discussions were always captivating, but some of his theories remained unconfirmed due to a lack of necessary technology. But there's hope. A single scientific instrument is making a huge impact, and we aren't ready for what it will reveal. It's called the James Webb Space Telescope, JWST, and it is designed to explore the deepest parts of our universe. Let me tell you, JWST is no ordinary telescope. It's an engineering marvel, a testament to human ingenuity. Sure, we've launched other space telescopes before and they have served us well. But this powerhouse is truly exceptional. Compared to the Hubble Space Telescope, which has provided us with incredible discoveries for years, the JWST is a monumental leap forward. And the price tag for this cosmic wonder? A staggering $10 billion. Yes, you heard that right. That's enough zeros to leave you breathless. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this project to life, along with contributions from more than 300 universities worldwide. However, with such an ambitious mission comes great risk. This is not an endeavor for the faint-hearted. The JWST is venturing into the unknown, pushing the boundaries of what we know, and taking us to places we've only dreamed of. After a successful launch, NASA recently announced that the telescope has enough fuel to last more than twice its initial mission lifespan. Since its launch, JWST has achieved several incredible milestones. It traveled more than 1 million miles to reach its orbit around the Sun, where it will remain indefinitely. During its journey, the telescope successfully deployed its enormous 5-layer sunshield and giant primary mirror, both of which had to be folded to fit inside the launch vehicle. Now, after NASA has adjusted and calibrated it, the telescope is almost ready for full operation. One of the most exciting moments came when NASA announced that the JWST had captured its first images of starlight. The first image taken by the telescope was of a star called HD 8446, resulting in a mosaic of 18 scattered bright spots, light captured by the 18 mirror segments on the primary mirror. Later, NASA released another stunning image of HD 8446, where the 18 unfocused duplicates of the star were aligned into a deliberate hexagonal arrangement. Once the observatory successfully aligns the individual mirror segments, it will begin the process of stacking images, blending 18 images into one clear view. Thanks to its cutting-edge technology, the JWST will help scientists study the earliest stages of the universe after the Big Bang. It will focus on. Thanks to its cutting-edge technology, the JWST will help scientists study the earliest stages of the universe after the Big Bang. It will focus on how the first galaxies formed, how stars and planets emerged, and whether conditions exist for life elsewhere in the cosmos. The telescope's infrared capabilities allow it to peer through thick clouds of dust and gas, revealing celestial objects that were previously invisible to other telescopes. Unlike Hubble, which primarily observes invisible and ultraviolet light, JWST specializes in infrared imaging, making it uniquely suited to study the most distant and ancient parts of the universe. With its ability to detect faint light from the early cosmos, JWST may finally answer some of the biggest mysteries in astrophysics. Scientists hope to use it to observe exoplanets, planets beyond our solar system, and analyze their atmospheres for signs of habitability. Could JWST detect the chemical fingerprints of life? Some researchers believe it's possible. But that's not all. JWST will also provide new insights into black holes, particularly supermassive black holes that sit at the center of galaxies. By studying how these cosmic giants interact with their surroundings, we may finally uncover how they formed and grew to their immense sizes. Another groundbreaking aspect of the JWST is its ability to examine dark matter and dark energy, two of the greatest enigmas in modern physics. Scientists know that dark matter makes up most of the universe's mass, yet they have never directly observed it. Dark energy, on the other hand, is thought to be responsible for the accelerating expansion of the universe. With JWST, researchers hope to gather crucial data that could reshape our understanding of the cosmos. Since becoming operational, JWST has already delivered breathtaking images of deep space, capturing never-before-seen details of nebulae, star clusters, and distant galaxies. One of its first full-color images, released by NASA, showcased a deep-field view of the universe, revealing thousands of galaxies in a single snapshot, some of which formed over 13 billion years ago. This unprecedented look into the past allows scientists to witness the universe in its infancy, helping to confirm and refine existing theories about cosmic evolution. Every new image from JWST is like a page from the universe's history book, waiting to be read and interpreted. But what if JWST goes beyond what we expect? What if it uncovers evidence that challenges everything we thought we knew? Some theorists speculate that the telescope might detect anomalies, signs that we live inside a simulation, that the laws of physics are different in other regions of the cosmos, or even that we reside within a black hole. The possibility that our universe is contained within a black hole is an idea that has fascinated scientists for years. Some physicists propose that what we perceive as the Big Bang could actually be the event horizon of a massive black hole in another universe. If JWST gathers evidence supporting this theory, it could revolutionize our understanding of reality itself. Of course, these ideas remain speculative for now, but that's the beauty of science. It continuously evolves as new discoveries are made. The JWST represents a new era of exploration, one where we are no longer just observers but active seekers of cosmic truth. As the telescope continues its mission, we can only imagine what astonishing revelations await. Will it confirm existing theories or introduce new ones? Will it bring us closer to understanding black holes, the origins of the universe, and perhaps even the existence of extraterrestrial life? One thing is certain, The James Webb Space Telescope is just getting started, and the future of astronomy has never looked more exciting. Occurred after the first stars shaped in a period known as the epoch of reionization. This alludes to the point when neutral hydrogen was reionized, made to have an electric charge again, by radiation from these first stars. This incorporates looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also support finding exoplanets, which are exceptionally difficult to detect due to how they interact with their host stars. Its powerful sensors will actually be able to observe these planets in more detail, sometimes even imaging their atmospheres. Understanding the conditions and states of these planets could help researchers predict whether certain planets are habitable or not. Furthermore, in studying the formation of planets, analysts are also examining galaxies to understand how matter is organized on a large scale. This, in turn, helps us see how the universe evolved and how the spiral and curved galaxies we see today formed from different shapes over billions of years. One of JWST's goals is to look back at the earliest galaxies to better understand that development. Scientists are also working to comprehend how we got the variety of galaxies that are visible today and how galaxies continue to form and evolve. But most importantly, the James Webb Space Telescope will help us answer the greatest questions of all. Are we alone in the universe? And are we living inside a black hole? The JWST has already been on the hunt, and guess what it found? Compounds called polycyclic aromatic hydrocarbons, PAHs, hiding around those massive, supermassive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures are the goth children of the universe. They're everywhere, from distant galaxies to comets and even in our own solar system. Now, they're not just fascinating because they could be the building blocks of life but also because they help astronomers track star formation. When ultraviolet radiation hits these PAHs, they glow and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument, MIRI. This is usually a sign that there are some hot, young stars nearby. But wait for the twist. A curious astrophysicist, Ismail Garcia Bernard from Oxford University, decided to study 3 active galaxies, NGC 6552, NGC 70319, and the famous Stephan's Quintet, located millions of light-years away in the depths of space. What Garcia Bernard found will send chills down your spine. In the central regions where the black holes dominate, he discovered a lot of PAHs. Sounds intriguing, right? Well, here's where it gets eerie. The radiation near those enormous black holes twisted the PAHs, essentially transforming them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs disappeared into the darkness. Imagine being consumed by the darkness itself. But wait, there's a flicker of hope, or maybe not. The real question here isn't whether we're alive, but whether we truly exist. Does everything around us exist because of the black hole we're in? Everything seems to align with the theory that maybe we're not just living inside a black hole, but rather inside the event horizon, a boundary between the universe we know and the unknown. Could it be that everything is connected inside a black hole? The James Webb Space Telescope is out there right now, searching for answers to the unknown. Stay tuned, maybe it will make all of us rethink what we thought we knew about existence. Reality might be far more warped than we realize. In the fascinating world of astronomy, few subjects have generated as much curiosity and mystery as black holes. These massive entities, with their ability to bend space-time and consume everything in their vicinity, have long been the subject of both scientific study and popular imagination. The claim that we have finally discovered what lies inside a black hole, made by renowned physicist Michio Kaku, has sparked both awe and speculation. But what does this bold statement really mean? Has science truly unlocked the secrets of what exists beyond the event horizon of a black hole? To understand Kaku's explanation, we need to take a step back and examine the nature of black holes, the current state of research, and the significance of the latest discoveries in the field. The mystery of black holes. A black hole is a region in space where gravitational pull is so strong that not even light can escape. This phenomenon occurs when a massive star collapses under its own gravity after exhausting its nuclear fuel. When this happens, the star's core contracts, and if the mass is great enough, it forms a singularity, a point of infinite density where the known laws of physics break down. Surrounding this singularity is the event horizon, the boundary beyond which nothing can escape, not even light. For decades, the existence of black holes was purely theoretical. The concept first emerged from Albert Einstein's general theory of relativity, but it wasn't until the 1960s and 1970s that scientists like John Wheeler, Roger Penrose, and Stephen Hawking developed the mathematical framework that brought black holes into the realm of accepted science. Despite these advancements, black holes remain shrouded in mystery. What happens beyond the event horizon? Is it possible to see inside a black hole, or is it forever beyond our reach? The event horizon, a point of no return. The event horizon of a black hole is often described as the point of no return. Anything that crosses this boundary is inevitably pulled toward the singularity at the center, where it is crushed to an unimaginable density. Due to the nature of black holes, we cannot directly observe what lies beyond the event horizon. Since light itself cannot escape, the interior remains a realm of theoretical physics and speculation. For a long time, black holes were thought to be cosmic prisons, where all information about the objects that fell into them was lost forever. This idea led to the famous information paradox, a problem first proposed by Stephen Hawking in the 1970s. Hawking suggested that black holes might gradually evaporate due to a quantum process known as Hawking radiation. However, if this radiation carried away all the information about the matter that fell into the black hole, it would violate a key principle of quantum mechanics, a concept known as unitarity, which states that information can never be completely destroyed. This paradox sparked decades of debate, with physicists searching for a resolution. Could black holes actually preserve information in some unknown way? Or does the universe somehow rewrite the laws of physics at the event horizon? Recent discoveries and the future of black hole research. Thanks to cutting-edge telescopes like the James Webb Space Telescope (JWST) and advancements in quantum physics, scientists are closer than ever to understanding the true nature of black holes. Some researchers believe that information may be encoded in the event horizon itself, while others suggest that black holes could be gateways to other dimensions or even parallel universes. If Michio Kaku's statement is correct, that we have finally uncovered what lies inside a black hole, it could revolutionize our understanding of the fundamental nature of reality. Are black holes truly one-way doors to oblivion, or do they hold the key to the fabric of the cosmos? Are we living inside a black hole? One of the most mind-bending theories in modern physics suggests that our entire universe might actually be inside a black hole. According to this theory, the Big Bang, the moment when our universe began, could have been the result of matter collapsing inside a black hole in another universe. If true, this would mean that every black hole in our universe could be the seed of a new universe, endlessly repeating across cosmic scales. Could it be that everything we know, space, time, galaxies, and even ourselves, is merely a holographic projection from the event horizon of a black hole? Final thoughts. The search for answers continues. The James Webb Space Telescope and future space observatories are pushing the boundaries of our understanding, probing deeper into the universe than ever before. Perhaps, in time, we will finally unravel the secrets of black holes, and with them, the secrets of existence itself. Until then, the universe remains as mysterious as ever, leaving us with more questions than answers. Stay tuned, because the cosmos is far stranger than we ever imagined.